Hello everyone, today I'm going to talk about my process of solving machine learning problem using Mathematica. You can find the dataset on Kaggle. The dataset is about Amazon review. This is a simplified version which consists of 40,000 Amazon customers input sentences and labeled as positive or negative. You can regard it as the output. The target of this task is to classify the new coming reviews automatically using machine learning knowledge. Because raw data contains several useless information, it is necessary to preprocess those data, except for removing punctuations, numbers, and URLs. I also did the following tasks. Firstly, I convert all of the characters to lowercase because uppercase words doesn't have any spatial meaning for sentiment. And secondly, I also remove stop words, and thirdly, I remove some meaningless words, and those words are selected by us without all words based on the affixes in the given site, and remove top 100 meaningless words from it, including city and years and everyone, every day, something like it. And finally, we also stemming the word. Here is one example of preprocessing. Perhaps somebody claims that removing those words triggers information losing. But based on my experiment, not only can preprocessing increase efficiency, but also lead to higher accuracy thanks to less noise. Okay, now let's move on. Let's talk about algorithm I used for training. I used 3 different algorithms: random forest, neural network, and support vector machine. During the learning, I changed the parameters and get different performance of them. The performances will be discussed in the next part. Let's focus on those 3 algorithms. Firstly, it's about the random forest. The forest means plenty of trees, so it is formed of many decision trees. You can change the tree numbers, and also the main advantage of it is about the efficiency. It can run efficiently for a larger database and also based on the previous researchers. It produces a high accuracy on larger data sets. And secondly, it's about neural network. It is widely used for the deep learning area, but the major problem is about the efficiency. Even though it can perform quite good if you have the larger number of hidden layer, the training time is the main limitation of it. And finally, the one additional algorithm I put in this task is about support vector machine. This is ranked number 3 algorithm in top 10 algorithm in data mining, published in 2008. It can reduce the dimension of input data and implement training process efficiently, and also with the support of support vectors, it can enlarge the margin and so that it could find the best pipeline to classify data. Okay, let's talk about the performance of them. This is a general overview of accuracy of those 3 different algorithms versus the training set size. As can be seen in this plot, performance of random forest didn't as good as other tools. It is around 60%, and it's due to the overfitting and noises. Because random forest is more likely to be biased by noise. If we increase the training set size, the results may change. I mean that the random forest performance should be increased dramatically. But for this, it's not. The SVM and neural network have around 80% accuracy. They are quite good, what's more. Based on my experiments, the SVM took much less training time than neural network. Then, let's scrutinize them in detail. Even though the sizes of those pictures are small, you can find them in the notebook. The left-hand side picture shows precision and the recall, where the ROC curves are presented in the right-hand side. In ROC curve, all of those 3 lines are in the left corner, which means that the learning process of all of them are not bad. The positive recall decreases as the training size gets larger. However, the precision of the positive is opposed to recall. So I conclude that less negative reviews are mislabeled as positive. On the contrary, negative recall increases simultaneously. This is obvious because less reviews labeled positive means more of them regarded as negative. Okay, the code will be put on GitHub and the link is listed below. Thank you for listening. If you have any question, please feel free to ask me. Thank you.